Introducing the Hexabe 6000 by Creo & Kids, the coolest new toy this holiday season.
Whoa!
Its teardrop aerodynamic design alongside its durable lightweight propellers help it soar high into the sky.
I want one!
The carbon fiber lightweight base has 6 propellers with rings to fly higher and protect it as it flies. Now here's our design team with our design thesis.
Hi everyone! This is the design team with Creo & Kids Incorporated, and we are so excited to share with you our newest toy launch for the 2016 holiday season. This right here is the Hexabe 6000 drone, and we thought a lot about how to make this drone as durable and aesthetically pleasing as possible. So as you can see, it's a hexacopter, meaning that it has 6 motors and 6 propellers. And we did this on purpose because even though the most common type of drone on the market these days is the quadcopter, and here's an example of one, we thought a hexacopter would be much more better suited for a toy. And that's because if a toy happens to go into a tree or, for example, hit a wall, and one of these propellers is bent or destroyed somehow, it would be very hard for this drone to stay in flight because it would become this quasi tricopter type of shape and just simply crash. If, however, this happens to the Hexabe, because it has 6 propellers and this symmetric shape around the body, if one or maybe even 2 of these propellers are somehow bent, it can still stay in flight long enough so that it doesn't need to crash land and it can just land softly. So that instead of having to replace your whole toy drone, you can just replace 1 or 2 of the propellers. And also because this is a toy, and we know that children like to play a lot with the toys they love, we have these wings that extend into rings around the propellers to not only protect the propeller from damage if it hits something, but to also, for example, protect the wall. Of course, another important aspect to consider are the aerodynamics. And as you can see here, we gave the Hexabe a curved top to resemble the so-called teardrop shape that is known to be aerodynamic, like for example in an airplane wing. And we also chose the materials to be as light as possible. We made the body and the arms you see here supporting the wings out of carbon fiber because it is one of the most durable and light materials on the market. And to try to keep the price down, we made these wings out of foam, which is just as light as carbon fiber, but much cheaper. And then the rest of the parts, the propeller, the pin, the motors, and the landing gear here are made out of aluminum, which is durable, of course, and also inexpensive, and for how durable it is actually very light. And here we have dimension tolerance drawings of the platform, motor, and pin. And as you can see here, this is where the motor attaches to the platform, and it has a diameter of 20 millimeters. And for this fit between the platform and the motor, we used a locational transition fit so that the motor could fit as tightly and accurately to the platform as possible. And we used a whole basis fit so that the motor could be interchanged on the platform as needed. And then for this 8 millimeter diameter fit between the motor and the pin, we used a locational clearance fit so that the pin can move freely and be interchangeable as necessary. And then finally, for the 8 millimeter diameter fit between the pin and the propeller, we used a force tolerance so that the torque could be transmitted from the pin to the propeller as efficiently as possible.